Okay, so here we have ended yesterday. Now, if you look at this question, if you see in this question, they are asking about the most likely shape of the hydrazine molecule. So first we work on the nitrogen atom, which is the central one, and it have a 5 valence electrons, right? So it means that normally it is going to make three
Yes.
bonds and it has a one lone pair. So it has a three bond pair and one lone pair. If this is the case, we know that the bond angle is going to be 107 degrees, right? So that is our D option, which is going to be correct, and A, B, and C are wrong ones. Is this understandable?
Yes, sir.
Okay. Now here in this, they are they have given you the structure of an antidote molecule, and they ask you to arrange the angles in the decreasing size of the bond angle. So it means that from bigger to smaller. So what we did, we figure out the bond pairs and the lone pairs. See, in this diagram, you are observing the lone pairs along, right? So, and then we identified the bond angles like X.
Yes.
Angle X has a 104.5 degrees because it has a two bond pair and two lone pair, right? Angle Y is going to be 109.5 because it has a four bond pairs and no lone pair. And angle Z has a 107 degrees because
Yes,
the
sir.
nitrogen atom has a three bond pair and one lone pair. So the biggest one is going to be Y. Then we have a Z and then we have a X, Y, Z and X. So Y, Z and X is the C option. Is this clear? Okay. Now have a look over here. See, only difference between these two questions are that in this question they have already shown you the lone pairs, but in this question they haven't shown you the lone pair, right? Because if you see the angle 3 on this oxygen, because it has a two bond pair, so it must has a two lone pair as well, but they didn't show. So you have to take the help of the periodic table to figure out the number of bond pairs along with the lone pairs to correctly identify the structure. Is this clear? Yes, Alishba.
Yes, sir.
Okay.
Yes,
Now,
sir. It's clear.
okay, that's fine. Now, uh, here we have diagrams of the different shapes. Like if it is linear, you can make it either horizontal like this or vertical like this. Whenever you have to draw the trigonal planar, you can draw the trigonal planar in this manner or as well as in this manner. Both are considered as correct, okay? Then bend can be drawn this way. Both the bends can be drawn by this way only, but the only difference is the bond angle. Okay. After this, we have a trigonal pyramid. Trigonal pyramid is always drawn 3D by showing one plane atom, one bond on the plane, one bond above the plane, and one bond below the plane. Whenever examiner asks you to draw the three-dimensional or 3D structure, you have to draw it this way. In the same way, for tetrahedral, as you have seen yesterday, I've shown you when we are keeping the two bonds on the plane, one bond is going above the plane and one bond is going below the plane, isn't it?
Yes, sir.
So that's how you make the 3D structure. And there is a one requirement from the Cambridge. You must keep in mind whenever you are making this 3D structure, this above the plane bond, which is shown by the bold line, and the below the plane bond, which is shown by the dotted line, must be adjacent to each other. If you put the normal bond between these two, then it is going to be marked as wrong. Okay.
Okay.
Then we have a trigonal pyramidal and octahedral. In C trigonal pyramidal, we have shown the bond which is 120 degrees, the bond angle, and the 90 degrees both are shown. And in hexagonal, sorry, in octahedral, all the angles are 90 degrees. We have seen yesterday. So we make them at 90 degree to each other. Clear till here?
Yes. Yes, sir.
Okay. Now have a look at this one. This one is a little, uh, students find this one a little difficult one because, and if you read this one, see, as I've said earlier, that the comprehension is very important. So, see, they are asking to write this reaction in terms of the shapes of the reactants and products, right? So, if I show you, I'm going to mark B and D both wrong, because if you see the position of a boron is in group 3, right? So if boron is in a group 3, it has a 3 bond pairs. It has a 3 valence electron, so boron will make 3 bond pairs and it has no lone pair, right?
Yes, sir.
So it means that it is a shape of a trigonal planar, not the pyramidal. So over here, if you see in B and D, BF3 is shown as trigonal pyramidal.
Yes,
That's why I marked them wrong. Is this clear?
yes, sir.
Okay. Now, if you see NMe3, so it would be very easy. N is bonded to 3Me, right? So nitrogen
Yes, sir.
is in group 5, so it has
And
a,
one lone pair.
so it is going to be trigonal pyramidal, right?
Yes, sir.
So see what they did, they instead of making the pyramid in this orientation, they make it in the opposite orientation to confuse the students, right?
Yes.
So it means that if you see this and this diagram is correct. So we already figured out B and D wrong because of this. But in reactants, whether it's A or C, both are considered as correct. Now, see, look at this boron. When the fourth bond is here, now it has a 4 bond pairs, right?
Yes, sir.
So it is going to be tetrahedral when there are 4 bond pairs, isn't it?
Yes, sir.
So see, over here, it is marked wrong because this is wrong, as after the fourth bond, it it's still staying in the, you know, uh, trigonal planar position. And here it is going tetrahedral. Is this clear?
Yes, sir.
Okay. So I think this would be very easy. You have to figure out the bond pair, the lone pair, the covalent bond, and the coordinate bond, right?
Yes, sir. What is meant by the coordinate bond?
Dative bond.
So, dative.
Yeah, see, I have mentioned over here, if you see, coordinate covalent bond or dative bond.
Okay.
So, see, a coordinate bond is formed by a pair of electron by one atom, right?
Yes, sir.
So here, this pair, the both are cross, which is indicating that it is shared by only one atom, right? So that is a dative bond or
Yes,
a
sir.
coordinate bond. A covalent bond has a pair with electrons from both the atoms, so that's why I encircled this. And a lone pair can be this one or this one. Is this clear?
Yes, sir.
Okay. Now, next we have a bond energy. So, what is bond energy? So, it is the amount of energy which is required to break a specific 1 mole of a specific bond, and more importantly, one mole of a specific covalent bond in the gaseous state, because bond energy refers to covalent bonds, not the ionic bonds or the metallic bonds. Okay.
Yes, sir.
So see, over here there is a 1 mole of a chlorine molecule, and in this chlorine molecule there is a one single bond. So 1 mole of a chlorine molecule has a 1 mole of a covalent bond, right?
Yes, sir.
So if it's gas and I provide it energy, and as a result it breaks down and gives 2 atoms, so it means 1 mole of a bond is broken.
Yes, sir.
So the amount of energy that is absorbed or that is taken in when this bond is broken, that 1 mole of this bond is broken, that is called bond energy. And for chlorine, this is this much amount, positive 242 kilojoule per mole. Is this clear?
Yes, sir. Will this energy be given in the data sheet?
Yeah, that is given in the data sheet. Okay, so see, from this energy, what can we figure out? What is the value of this energy will help me to figure out the strength of the bond, right?
Yes, sir.
If it's greater, then it means that that bond is strong, right? And if this is smaller, the value is smaller, then that this bond is weaker, right?
Yes, sir.
Okay. So it means bond energy depends upon reactivity. If the bond is stronger, so it means it needs a lot of energy to break.
Yes.
So if it needs a lot of energy to break, so it would be reactive one, or more reactive or less reactive?
More reactive.
If it needs more energy to break, so will it be more reactive?
Less reactive.
Less reactive. And if this bond energy is very small value, so it means it's need a very little amount of energy to break. So it means that bond is reactive, right?
Yes.
Okay. Next one is a bond length. So what is the bond length? Bond length is the distance between the nucleus of the two atoms, which are covalently bonded. Okay. Now
Okay.
think, if the bond length is bigger, it means that the two atoms are at a more distance. Then what do you think, that bond has a greater bond energy or a lower bond energy?
It has a lower bond energy.
Has a lower bond energy. It's a simple thing. For example, if you have a smaller stick, you need more energy to break it. But if you have a longer stick, you can break it easily, right?
Yes, sir.
So it needs lesser amount of energy. So it means it is more reactive. And if the bond length is smaller, so which means that the two nuclei are very close to each other. So then it means that it has a greater bond energy. So it is less reactive. Is this clear?
Okay.
So
Yes, sir.
over here in bonding, you have to understand the concept that both bond energy and both length affect the reactivity. So this is the relation. Bond energy is inversely proportional to the reactivity. It means the more the bond energy, the lesser the reactivity. The lesser the bond energy, the more the reactivity. Is this clear?
Yes, sir.
Okay. Bond length has a directly proportional. The more the bond length, the more the reactivity. Because as the bond length increases, the distance between the two atoms, the nuclei of the two atoms increases, its bond energy gets lower, isn't it?
Yes, sir.
Okay. Till here is all clear, or you have any confusion?
So, sir.
Okay. There is one more thing. Now, the next thing that we need to discuss is electronegativity. So, what is electronegativity? It is an ability of an atom which attract the shared pair of electron itself, or you can just say that it is an ability of an atom to attract the electrons towards itself. Okay.
Okay. So all the
So
non-metals would have higher.
it is usually observed in covalent bonding. For example, if I take the example of hydrogen, let's suppose. So these both hydrogen atoms are attracting these electron pair towards themselves.
Yes, sir.
So that ability to attract this pair of electron towards themselves is called.
Electronegative.
Is this understandable?
Yes, sir.
So if the electronegativity value is greater, then it means that atom has a more or stronger power to attract the shared pair or bond pair of electron towards itself. This is the Pauling's electronegativity table that is given in the data sheet or in the data booklet. Okay. So here, if you see the scale, if you see fluorine has the value of 4 and rest of the elements has the value electronegativity value lesser than this, right?
Yes, sir.
So it means among all the elements, the most electronegative one is fluorine. Okay, can I ask you a question?
Yes, sir.
Why there are not noble gases over here?
Because they all are stable, they don't react.
They don't bond, right?
Yes, sir.
Yeah, that's why. Good.
And whatever element has the highest electronegativity, that's going to have a more amount of bond energy.
No, it's not necessary, but it has a more share of a dead bond pair with it. For example, if it is going to bond with the hydrogen, let's suppose.
Mhm.
See, So what would happen? For example, this is the bond. So due to its higher electronegativity, this pair of electron is more closer to the fluorine as compared to the hydrogen. So the sharing of the electron pair is not going to be equal when there is a difference in the electronegativities of the two atoms which are bonded covalently. Is this understandable?
Yes, sir.
So that's the difference that this electronegativity create. Any confusion till here?
No, sir.
Okay. Now, factor affecting the electronegativity values. So these factors are exactly the same.
Which affected the ionization energy.
Yeah, which same as the ionization energy. Very good. So nuclear charge. So it means when the atom has a more number of electrons. Just give me a minute. Sorry, more number of protons.
Yes, sir.
Okay. So if it has a more number of protons in the nucleus, so it means it has a greater nuclear charge. So it means if it has a greater nuclear charge, so it is able to share the electron pair more forcefully, right? Which means it has
Yes, sir.
electronegativity value. Is this clear?
Yes, sir.
Now atomic radius or atomic size. So as the atomic radius or atomic size gets bigger, for example, the shared pair is over here. And in the second case, the shared pair is over here. So see, the distance gets bigger.
It's closer to the smaller one. Yes, sir.
So what happens with the greater distance?
The shear pair gets further away
Yeah.
and it's closer to the other nucleus.
Don't talk about the other nucleus, just compare these two. So due to the bigger size, the shared pair gets further away. That's fine. So what happens as a result? As a result, as nucleus and the shared pair are away from each other, the forces of attraction gets weaker.
Electronegativity.
The electronegativity decreases. Very good. Is this clear?
Yes, sir.
Okay. Now we have a shielding effect. So it is again same. The more the shielding effect is there, the more weaker the forces of attraction gets weaker, and the lower the electronegativity gets. Right?
Yes, sir.
So we have these three factors. Electronegativity is directly proportional to the nuclear charge. The more the nuclear charge, the greater the electronegativity. The bigger the atomic size, the lower the electronegativity. The greater the shielding effect, the lower the electronegativity, because there are more number of electron shells which provide shielding effects. So hence the forces of attraction gets weaker, and hence the electronegativity gets weaker. Is this clear?
Yes, sir.
Okay. Now periodic table trend. So down the group, electronegativity values decreases. Okay.
Yes, sir.
Because the same thing that when we move down the group, if you see, for example, let's
The
look.
shielding effect is increasing
Nuclear charge
and
is
the
increasing,
distance.
how? Right?
Yes, sir.
But the distance is increasing. Shielding effect is in
Yes, sir.
both shielding effect and distance outweighs the effect of nuclear charge, hence the electronegativity decreases.
Yes, sir.
And if we move across the period, the shielding effect remains same. The nuclear charge increases, the force of attraction gets stronger, the size decreases, and hence the electronegativity increases down
Increases.
across the period. Okay.
It's
Okay.
the same as ionization energy.
Yeah. The fluorine is the most electronegative element. You have to remember this, and you have to remember the order of the most electronegative elements. You can recall it by Frenkel. Fluorine, the most one, then oxygen, then nitrogen, then chlorine. Till here, is this clear?
Yes, sir.
Okay. Great. Now, how electronegativity difference affect the nature of bond? That is very important to understand. Okay. So look at three cases. In the first case, if you see that the shared pair of electron is exactly at an equal distance from both the nucleuses, isn't it?
Yes, sir.
So it means that what will be the electronegativity difference between these two?
It would be minimum.
There would be no or minimum, yeah. There would be a significant difference between the electronegativity values between these two. That's why the shared pair of electron gets closer to the C atom and gets away from the A, right?
Yes, sir.
And here the electronegativity difference is so huge that instead of sharing, it took away the pair of electron, make it an anion and making the other atom cation, and hence ionic bonding is there. Did you understand these three differences?
Yes, sir. But that is the result of it, right?
Yeah,
Because
that is the result.
electronegativity does not affect an ionic bonding. It's only covalent bonding.
Yeah, but for example, I'm going to give you, yeah, it affects the covalent bonding, but if the two atoms which are going to bond has a huge difference in their electronegativity values, okay, then as a result, they are not going to make the covalent bond, they are going to make the ionic bond.
Okay.
Understandable?
Yes, sir.
For example, have a look over here. We usually observe a covalent bond between hydrogen and chlorine, right?
Yes, sir.
To see what is the difference between these two, the electronegative value. If I take out the difference, isn't it 0.9?
0.9. Yes, sir.
But sodium chloride is ionic, right?
Yes, sir.
So if you look at the difference between sodium and chlorine, it's 2.1.
Yes, sir.
See, when the difference gets huge, so due to this very high difference, when sodium and chlorine are going to bond, they are not going to make the covalent bond. They are only going to make
They're
the
gonna make ionic.
due to the high difference. Is this understandable?
Yes, sir.
Okay, so see, this is the case. Here, as we discussed that there is a minimum electronegativity difference or it's similar. So this is the case when the difference in the electronegativity ranges from 0.0 to 0.4. Okay.
Sure.
And that's when we call it non-polar covalent bond, like hydrogen-hydrogen, like carbon-hydrogen. If you see carbon and hydrogen, their electronegativity difference is almost 0.4 or 0.5. Okay.
Yes.
Now,
So it would be the same for chlorine gas, oxygen gas, because
yes,
they all
chlorine,
have
chlorine,
minimum.
oxygen, oxygen. Yeah. But if there is a bond between carbon and oxygen, that it is not going to categorize in this. If there is a bond between
There's
hydrogen,
gonna be a difference.
yeah,
Yes, sir.
there is when this is the case, then difference lies between 0.5 to 1.7, and we call it polar covalent bond.
Okay.
Okay. And when the difference goes
Yes.
greater than 1.8 between the two elements, then it is ionic bond.
Okay.
Is this clear?
Yes, sir.
Equal
What is
to,
the difference between non-polar and polar?
yeah. See, non-polar. Try to understand this term. It is derived from no poles. Polar
Yeah.
means have poles.
Non-polar is it's at the middle of polar is at one pole of the bond.
Sorry, can you repeat?
Non-polar is that it's in the middle of the bond, and
Yeah,
polar
yeah.
is it's at one pole of the bond.
No, you can't say it's one pole of a bond. As you see, here the electron pair is equally shared, right?
Yes, sir.
So if it's equally shared, as a result, it is completely neutral and it has no pole. And here I said that polar means have poles. So how it has poles? Let's see. For example, here it got a negative charge, a whole negative. Why? Because it took away one electron from the A, right?
Yes, sir.
And here it got a positive charge because it lost its one electron, right?
Yes, sir.
But if you see this case, it is the intermediate situation of these two, isn't it?
Yes, sir.
The electron is shared, but that shared pair is not equally shared between those two atoms, isn't it?
Yes, sir.
So which atom has a more part of electron?
C does.
C does. It has a more part of a shared pair, right?
Yes, sir.
And what is the charge on electron?
Minus.
Negative.
-1.
So that makes this C a partial negative. This is complete negative. It is partial negative. Getting the point?
Yes, sir.
And this makes partial positive, isn't it?
Yes, sir.
So that's what we call dipole. Dipole means two poles. See, two poles are created.
Yes.
So that's what a polar covalent compound means.
Oh.
Understandable?
Yes, sir.
If you have any confusion in this, please ask.
Not here. We'll see more examples. It'll become more clear.
Yeah, we will see. So see, non-polar means it has a no charge and it has a no net dipole. See, dipole, normally student doesn't able to, interpret this term. Di means two. So it means they are talking about two poles. So here we are not getting any pole. But here, as due to the charge is separated partially, and this one is getting partial negative and this one is getting partial positive, that's why this get a dipole. And dipole means it has a partial charges. And when there are ions, the ionic compound, it has an ionic bond between ions, and ion means there are whole complete charges. Is this clear?
Yes, sir.
Okay. Now, when there is a non-polar covalent bonds, the molecules are also considered as non-polar. Okay. But when there is a polar covalent bond, then molecules can be non-polar and polar. There are both the possibilities. Okay. And we are going to see how we will figure out whether the molecule has a dipole and it's going to be polar or not. So see, in polar molecules, what happens? The dipoles cannot cancel, right? And hence there is a net dipole. For example, if I talk about HCl, obviously chlorine is more electronegative, which makes it partial negative, and hydrogen is partial positive. Is this clear?
Yes, sir.
So see, there is a dipole, right?
Yes, sir.
Okay. What happens in non-polar? Dipoles cancelled out each other, hence no net dipole. Okay. Can you recall the shape of carbon dioxide?
Two lone pairs and two bonds. It's trigonal planar.
Trigonal planar. Are you sure? How many bond pairs around in carbon dioxide around carbon?
Lone pairs are like carbon is only
How many electrons carbon has?
4.
4. So it needs 4 more, right?
Yes, sir.
How many electrons oxygen has
6.
in its valence shell? So it needs 2 more. So carbon makes a double bond over here and a double bond over here. Do carbon has a lone pair?
No, it does not. Oxygen has a lone pair. I wasn't considering carbon as a center.
So carbon is a center. It has a 2 bond pairs and no lone pair. So what would
It's
be the shape?
linear.
It's linear. Now look at
Yes, sir.
oxygen in water. Oxygen has a 2 bond pairs
Hmm.
and 2 lone pairs in water, right?
Yes, sir.
So what would be the shape of water molecule?
It's gonna be linear bend.
Bent, not linear. You can call it non-linear or bent. It's not linear, okay?
Okay, sir.
Because the angle is not 180. Linear is the case when the angle is 180, okay?
Yes,
So
sir.
here it's a bent. Now see, if I consider this bond, isn't it a polar bond?
Yes.
But see, as the angle is 180 degrees, so both the dipoles are exactly opposite to each other, which will cancel out each other, and as a result, the molecule become non-polar, although it has a polar covalent bonds.
Okay.
But if you see over here, it is also a polar bond over here, right?
Yes.
But on opposite of this hydrogen, there is no atom, and opposite of this hydrogen, there is no hydrogen. And their bond angle is 104.5. So the both the hydrogens are not exactly opposite to each other, right?
Yes, sir.
So it means their dipoles are not going to be cancelled out, and hence water is going to be a
Polar molecule.
polar molecule. Good. Understood?
Yes, sir.
Okay. So dipoles, as I have discussed earlier, means two poles. So two covalently bonded atoms have a partial charges represented by partial negative, partial positive, which means less electronegative, and partial positive means less electronegative, and partial negative means more electronegative, and it is due to the electronegativity difference. Till here, is this clear?
Yes, sir.
If you have any query, any question, please ask.
Not here.
Okay. Okay. Now, the polar molecules have net dipole because they have a polar covalent bond, and dipoles on bonds are not cancelled. And if the molecule has a polar covalent bond and dipoles on bonds are cancelled, then the molecule is going to be
Non-polar.
non-polar. And if the polar covalent bonds are there and dipoles on bonds are not cancelled, then it is
Polar molecule.
polar molecule. And if the bonds are non-polar, so the molecule is non-polar and it has no net dipole. Is this clear?
Yes, sir.
So if you look at all these examples, these are going to be non-polar or polar?
Yes, sir. It's gonna be non-polar because they all are canceling their electronegativity.
No, there is no electronegativity difference. So they are non-polar bonds over here. See understand the difference. See, if I compare these two, both are non-polar molecules, right? But here
Yes, sir.
it is non-polar molecule because its bond is non-polar.
Yes, sir.
And here the bond is polar, but the dipole is
Molecules are.
cancelled out over here. That makes it
Yes, sir.
non-polar. Clear?
Okay.
So
Yes, sir.
these have a non-polar bonds.
Okay.
Okay. So the
Yes, sir.
difference in electronegativity is zero because non-polar covalent bonds, there is no dipole, and hence the molecules are non-polar. Okay. Now have a
Yes,
look.
sir.
HCl and carbon monoxide both has a dipole, right?
Yes, sir.
So it means the bonds are polar covalent.
Yes, sir.
They have a net dipole, or their net dipole is
Yes, sir.
cancelled.
They have a net dipole.
They have a net dipole, so the molecules are going to be polar.
Yes, sir.
Now have a look at these. See, it has a polar bond. It has a polar bonds. It has a polar bonds. But these bonds are oriented in such a way that their dipoles are cancelled out, and as a result, we get a non-polar molecule, although there is a polar covalent bonds in them. Is this understandable?
Yes, sir.
Okay. Another way to understand this. See, for example, if I make the molecule, this molecule is going to be like this.
Hmm.
This molecule is going to be like this.
Yes, sir.
This molecule is going to be, for example, like this.
Yes, sir.
So look at the end. This end is getting negative charge, and this end is also getting the negative charge, isn't it?
Yes, sir.
This end is getting the negative charge. This end is getting the negative charge over here, right?
Yes, sir.
Here it is a negative. Here it is a negative. Here it is a negative. See?
Hmm.
But if I look at this molecule, this end of the molecule is negative and this end of a molecule is positives.
Yes, sir.
So see, I am getting the two different charges at both the ends, right?
Yes, sir.
Polar molecule. On all the sides, I am getting same charges or on all the ends, isn't it?
Yes, sir.
So non-polar molecule, no net dipole. Is this clear?
Yes, sir.
Now have a look. If I make the shape, it's going to be like this, but see, this end is becoming negative and this end is becoming positive, isn't it?
Yes, sir.
If I make this, like for example, it's a shape, this end is positive and this end is negative.
Yes, sir.
Okay. If I look it over here, this end is negative, this end is positive. And further, if you see the direction, they are oriented in such a way due to the bent shape and pyramidal shape, their dipoles are not cancelled out, which makes them that polar molecules and have a net dipole. Is this understandable?
Yes, sir.
If you have any confusion till here, please ask.
No.
Okay, now have a look over here. Obviously, this one has no net dipole, right? Because see, there are 4 bonds. In the middle, it is negative. This is positive. This is positive. This is positive. This is positive. So all the corners are partial positive, which makes it no net dipole, right?
Yes, sir.
But if I may put a chlorine on one and replaces the one hydrogen with the chlorine, this becomes negative with respect, and this carbon becomes partial positive with respect to this chlorine. But this carbon is also partial negative with respect to this hydrogen. Are you getting this point?
So, element could be partial negative and positive at the same time,
At the same time,
but
with
with
respect to
difference.
the other atom to which bonded, if I am comparing this
Okay.
carbon with the hydrogen, then this
Hmm.
carbon is considered as partial negative.
But with chlorine, it's partial positive.
Yeah, because chlorine is the most is among the one which are most electronegative, right?
Yes, sir.
So due to this, if you see this case, then this end becomes negative and this whole side becomes positive.
Yes, sir.
So it makes it that it has a net dipole and it's a polar molecule.
Yes, sir.
The same case over here. If you have any query till here, please ask.
No, sir.
Okay. So here they ask you, which one of the following has no permanent dipole? So if I make this structure over here, see, there are 2 chlorines and 2 fluorines. So chlorine are going to be partial positive as compared to fluorine. Because if you
Yes,
recall
sir.
the order, fluorine is the most electronegative one,
Chlorine is the highest.
then
Yes, sir.
nitrogen, then chlorine. So, so in the whole molecule, we are getting one side partial negative and the other side partial positive, right?
Yes, sir.
So it has a net dipole. That's why A is not going to be the answer, because they are asking about which has no permanent dipole, right?
Yes, sir.
If I make this, here I have a hydrogen and here I have a chlorine. So isn't it, it has a partial net dipole?
Yes, one side is negative, one side is positive.
Yeah. In the same way, for example, if I look at this one, the D1, there is 1 chlorine and 3 hydrogen and just, so one side is become positive and one side becomes negative, isn't it?
Yes, sir.
Okay. But here, if you see, all the sides are negative, all the sides are negative in the option C, isn't it?
Yes, sir.
So it means it has a no permanent dipole.
So figuring out the dipoles, we don't actually use the electronegativity to see the to exact cancel. We also take in the angle and the shape.
Yeah. Yeah, we have to keep
Okay.
not only the electronegativity, beside electronegativity, we have to look at the shape as well.
Okay.
Okay. For example,
Yes,
if
sir.
the most common example is C, this one, the carbon dioxide and water.
H2O.
This is the most common example to understand. Here the dipoles are getting cancelled because the shape is linear, right? But here the
Yes, sir.
dipoles are not cancelled because the shape is bent, due to which it becomes polar, it has a net dipole, and it becomes polar and it has a no net dipole. Clear?
Yes, sir.
Okay. Now, see, they are asking about which has the largest overall dipole. So obviously, we know that oxygen is, okay. So A is going to be wrong in a way because it has a no net dipole because all are,
Negative.
negative. Okay. B has no net dipole because the dipoles are cancelled out.
Yes, sir.
Now we are left with B and C. Both has a net
Hmm.
dipole, isn't it?
Yes, sir.
But this is with respect to, because if you recall the order, oxygen is more
FONCl.
electronegative. Yeah, oxygen is more electronegative than chlorine.
Yes, sir.
So with respect to oxygen, chlorine is going to be partial positive.
Yes, sir.
And with respect to oxygen, hydrogens are also partial positive, right?
Yes, sir.
But the electronegativity difference between oxygen and hydrogen is way greater than the electronegativity difference between oxygen and chlorine, isn't it?
Yes, sir.
That makes it has a largest overall dipole and it has a smaller overall dipole. Is this understandable?
Yes, sir.
So we have to look at the difference in the electronegativity between the two atoms to figure out which one has the largest and which one has the smallest.
Okay.
Understandable?
Yes, sir.
Okay. Before going over here, I have to add one more point. Uh, that this is the net dipole has polar. It means they are polar. They are polar, right?
Yes, sir.
So polarity and reactivity. How polarity affects the reactivity? Okay, tell me about the reactivity of nitrogen. Is nitrogen is a reactive gas or a non-reactive?
Is a reactive gas
Where do you find nitrogen?
in the non-metal side, but it has
No,
high
no,
electronegativity.
no. I'm talking in our environment where we find a nitrogen.
It's in the air.
It's in the air. So do it react?
No.
It's non-reactive, right?
Yes, sir.
See, normally the packages, the food packings having the air in them, we say air in them, but it actually it's not air, it's nitrogen in them. Okay.
Okay. Yes, sir.
So just can you give me 1 minute, please?
Yes, sir.
Okay, that's fine. Yeah. So nitrogen is unreactive. What about carbon monoxide? Is it reactive or unreactive?
It's a poisonous gas. It is reactive.
It is very reactive, right?
Yes, sir.
But what is common in them? But both have
Have covalent bond.
triple covalent bond and bond energy is almost same.
I get how nitrogen has a triple covalent bond. How does COI has a covalent bond?
Look at the dative bonding we have discussed yesterday. Isn't it a third one is a dative one, isn't it? A pair of electron is there, right?
Oh, yes, yes.
Two covalent bond and third one is a dative one, isn't it?
Yes, sir.
Okay. Now let's have a look at their bond energy values.
Yeah, how would we figure out if an element has another bond and that's a dative bond?
Let me help you to figure out this one. Just give me a minute. See the bond energy of carbon oxygen triple bond?
Yes, sir.
1077.
Yes, sir.
And nitrogen triple bond?
944.
So it has a 944 kilojoule per mole. And it has a 107 kilojoule per mole. Right?
Yes, sir. But if the bond energy is higher, shouldn't it be unreactive?
Very good. See, now you start thinking. So the reason that it has a no net dipole, isn't it?
Yes, sir.
And do it has a dipole?
Yes, one side is negative, one side is positive.
So see, that makes it more reactive. How? Because if it is negative and this one is positive, so it can attract anything which is negative towards this side and anything which is positive toward this side, isn't it?
Yes, sir.
If, for example, there is, let's say, oxidine, let's say, so this can attract it towards itself, isn't it?
Yes, sir.
If in the same way, if there is anything positive, it is attracted towards this side, but this cannot attract anything towards itself.
Yes, sir.
So this, due to the dipole, it becomes very reactive. So see how polarity is affecting the reactivity.
Mhm.
Understandable?
Yes, sir.
So due to partial charges, or let me say dipole, carbon monoxide is very reactive and nitrogen is unreactive as it has no dipole. Let me add it over here and hi. Take the screenshot, add it in your notes.
Okay, sir.
Okay, so see, our first case that if the bond energy is higher, the molecule becomes unreactive. So see, it is observed over here. Yeah, it is unreactive. Its bond energy is very high, as it is almost same, right? 944 and 1000 is the difference between these two is not bigger. So apparently, carbon monoxide is going would have to be as less reactive or as unreactive as nitrogen, but it becomes reactive, and it becomes reactive due to this character, due to the polarity, due to the dipole or the partial charges on it. Is this understandable?
Yes, sir.
Okay. So now we have our intermolecular forces that I am going to continue in our next class. Okay. But your question, how
Yes,
can
sir.
we figure out that the molecule has a covalent bond or a dative bond? Actually, dative bond is also a type of a covalent bond. But if the examiner asks you to identify the covalent dative bond, then you will see. For example, let me make this dot and cross. There is a two pairs shared between carbon and oxygen,
Yes, sir.
right? And oxygen has two lone pairs as well. Now, if you see the pair
Yes.
that is shared has two different electrons, right?
Yes, sir.
So it means it's a covalent bond.
Covalent bond. Yes, sir.
Now, have a look over here. Now there is a 3 shared pair of electrons, and each shared pair has 2 different electrons, right?
Yes, still covalent bond.
They are still covalent bond.
Yes, sir.
So if there is a case that you will find that a pair has 2 same electrons,
That's a dative bond.
that's a dative bond.
But sir, for example, like you wrote CO has triple covalent bond.
Hmm.
How will we figure out like if a molecule has a
Okay, okay. It can be only identified when you try to make the, you know, dot and cross. So for example, if I try to make a dot and cross, I will first look in the periodic table. I will find that carbon has a 4 valence electron, right?
yes, sir.
So carbon can share how many electrons?
4.
4. Oxygen has how many electrons in its valence shell?
It has valence shell 6. It can
So
share 2.
2. So now think, carbon can able to share 4 and oxygen can able to share 2, right?
Mm.
And this
Yes,
carbon
sir.
is going to bond with this oxygen only right now. So how many electrons this carbon can share with this
2.
oxygen? 2. So
2.
you know that carbon can share 4, but right now
Mm.
this carbon is sharing its 2 electrons with the oxygen, and as a result, oxygen shared its 2 electrons with this carbon.
Yes, sir.
Okay. Now, to make this third bond, which is the covalent bond as the diagram says, how can you make this? Can you make this by sharing 1 electron from here and 1 electron from here? Is this possible?
No, that will be a covalent bond. It wouldn't be a dative
No,
bond.
but if you will make it,
Mm.
but if you know the concept, if you do it, for example, if you do it, now count the electrons of a carbon.
There are 7.
Now, and count the electrons of oxygen.
There are 10.
See? So it means if you did this way and you then check it, if you don't check it, you make it this way and you proceed further. But if you check it, so you will figure out that it's wrong, because after the bonding, both the atoms must have an octet.
Yes,
Isn't
they're
it?
exceeding their octave.
So neither oxygen
Yes,
gets an
one
octet.
is deficient in their octave, the other is.
Yeah. So now think another possibility. If it's not done, then think of another possibility by sharing the electron from 1. So what I did, I removed this pair and make it over here. Now count the electrons of both the atoms.
Carbon has 6 and
No.
oxygen.
Now carbon has 8, isn't it?
Yes, sir.
And oxygen has?
8.
See? Now 8 electrons of carbon and 8 electrons of oxygen. So see, both got octet. So both are getting octet in
Mm.
this way. So I can figure out from this that these 3 triple covalent bonds, 2 are simple covalent and 1 is dative.
Okay.
Is it clear, or still there is a confusion?
It is clear.
Okay. So shall we keep the class till here today?
Yes, sir.
Okay. So inshallah tomorrow we will be continuing intermolecular forces, but do go through these polarity and the dative bonding things, and if you have any problem in them, please ask. Okay.
Okay, sir.
Okay. Take care. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.